So today we continue to review factoring. We'll still pull out some GCFs, and then we'll be looking at ones that start with 1x squared and how we factor those. And we'll do some more with overlapping triangles, but this time we'll just focus on if those overlapping triangles happen to also be right triangles. Just an extra trick that we have in our toolbox to be able to solve those. So, factoring the ones that start with 1x squared. First thing we want to do is to factor out the GCF. I said yesterday, we always want to look for that first. A lot of times that's going to make the whole problem easier as far as finishing up what is left. And then once we have that, if they start with 1x squared, our factoring is going to be two short parentheses, just two terms in each, binomials, x plus or minus something times x plus or minus something else. The way that we figure out what these need to be, we look at that 1x squared plus something times x plus c. We look at the constant, the one that does not have an x, and we want two things that multiply to get that. And then we look at the one that is times the x, and we want those to add to be equal to that. We include the plus and minus signs that are with those numbers right before the x, or the constant at the very end of it. Then we keep those plus and minus signs that go with the two numbers we identify and put those in. So if we have +5, we do an x plus 5. If we have -7 as one of the two numbers we look for, we put in an x minus 7. And then always do just a quick mental math FOIL check. If you FOIL what you just wrote down, do you get what you started with? So let's do about 4 of these to practice this. You did a lot of these last year. Let's review these. This one, 1x squared, I'm good with that, but what do you notice about the next two numbers that aren't quite right? And a couple people doing this. They aren't quite in the right order that we're looking for. So we are thinking of this as x squared minus 6x minus 7. We're hoping for two parentheses that each start with x. They need to multiply to be the -7 and add to be the -6. Who can tell me two numbers? Raise your hand when you think of the two numbers that multiply to be -7 and add to be -6. What two numbers do that? Ayla. -7 and +1. What do you guys think? Is that what the others were thinking of? Let's put those in, including the -7 and the plus with the 1. Quick FOIL check. First times first is x squared. Outside times outside, I get a plus x. Inside, I get a -7x. Plus x minus 7x is the -6x. And last times last, -7 times +1 gives me the -7. So we are confident that this is our correct way to factor that one. Okay, next one. I'm going to get a little bit messier as we go down this page. This is not quite in the form that we talked about. It does not start with 1x squared. It's got something else in front of it. So it gets too messy and too confusing if we try to come up with a parenthesis that starts with a -x and one that starts with a +x. So we aren't going to do it that way. We are going to say, let's factor out the -1, and then we will have something that is in the form that we can factor most easily. So if I factor the minus sign out in front, I'll keep that as part of my final answer, but then I'm trying to factor x squared minus 6x minus 16. I had to change all of the signs there. Now I have to keep the minus sign. I'm looking for two parentheses that can each start with an x. What do they need to multiply to be? -16. What do they need to add to be? -6. Raise your hand when you can think of two numbers that will work for that, to multiply to be -16, add to be -6. Hayden. -8 and +2, thumbs up, thumbs down from the rest of you. So we will put in the -8 and the +2, doing a quick FOIL check. If I don't worry about the minus sign yet, if I FOIL, I get the x squared. I get the +2x and the -8x, which is a -6x. And the -8 times the +2 is a -16. And then if I distributed the minus sign, I would be back to what I started with. So all of this, including that minus sign, it would be our correct factoring for this one. Okay, third one of the 4. Tell me what you notice on this one that's kind of different. There may be more than one thing that you're noticing we have to do something a little bit different with. Riley, what are you thinking? So I can factor out a 3 and an x. If I just factor out an x, will that get me where I need to be? What are you thinking, Clay? Okay, so if I factor out an x squared, then I've got, or you said 3x squared. Then I've got 8 plus 7x minus x squared. That still doesn't look quite right to me, Ellie. So instead of factoring out a 3, let's factor out a -3 because we wanted to think about rearranging it. Usually I kind of rearrange it first, at least mentally. And then say, oh, I need to factor out the -3 and an x squared. So then we would have the -3x squared, and then we would have x squared minus 7x minus 8. Does that look right now for what we want to try to factor? Now we have something that starts with +1x squared. So now we are looking for two things that multiply to be what number? -8 and add to be what number? -7. Raise your hand when you can tell me what those two numbers should be. Waiting for more hands. What multiplies to be -8 adds to be -7. Marlo. -8, +1, thumbs up, thumbs down for that. So we'll put those in. And if we FOIL just this part, x squared, we'd have this. -8x and plus x, we'd have the -7x. -8 times 1, we'd have the -8. So all of these, including the GCF, that's how we would factor it. And just to make sure we get as messy as I can possibly come up with today, how about this one? Let's start with, does anybody see a GCF in there? Because maybe that'll clean it up and give us something that's easier to work with. Anybody see a GCF in this thing? What are we thinking? Are there any GCFs in there? Allison, do you see a GCF? Thumbs up, thumbs down for a squared b squared. So if we pull that out, then will that leave us things in the right order? So we really are going to want to start with this one so we can start with the x squared, right? So if I factor a squared b squared out of that, I've got x squared. This one's going to have the x in it. So if I factor out a squared b squared, I think I'm going to have plus 9x. And if I take the a squared b squared out here, I've got a plus 14. Does that look right? So what do they need to multiply to be for this one? And add to be, raise your hand when you can tell me those two numbers. It's going to multiply to be 14 and add to be 9. Harper. plus 7 and plus 2? What do you guys think? Quick mental math FOIL check. X squared plus 2x plus 7x. Yes, that's not plus 9x and plus 14. So there is our factoring for example 4. Yes. Nope. The parentheses can always go in either order. It does not have to be bigger and then smaller. It does not have to be positive and then negative. Just whichever one you think of first. Because of the commutative property, I can switch the order of the parentheses around. That's a great question. Any other questions before we move to triangles? All right. So once again, we have two triangles that overlap. Because these are right triangles, they're going to be similar, or they're going to be similar triangles. Let's start out with drawing our separated pictures, just like we did the other day when we had triangles that overlapped like this. So this one would be 5 and 4 and A. And the big one, if I don't have the parallel line running through it, would be a C. How big would the bottom be on that big triangle? So 8, and this one would be A plus B. These are both right angles. They both share this angle, so angle, angle implies angle, 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 so they're similar. Those right angles also mean that those lines are parallel, those two vertical lines, just like we saw on ones the other day when we did overlapping triangles. So just like what we did with the other overlapping triangles, we still have similar triangles. So we can set up ratios of sides. We still have proportional line segments, like we saw the other time that we had parallel lines running through the middle of the triangle. And because they're right triangles, we also have the Pythagorean Theorem. So when they are right triangles that overlap, we have 3 tricks in our toolbox that we can use. Whereas when we didn't have the right angle, we just had the proportional line segments and the similar triangles. So which one do you think is going to be easiest to get first, A or B or C, as you look at those now 3 triangle pictures that we have up there? Ayla? That sounds pretty good to me. So let's get A with the Pythagorean theorem. So we can say 4 squared plus 5 squared is A squared. So 16 plus 25, is that 41? Is A squared. So if I take the square root of that, A needs to be the positive square root of 41. Okay, which one do you think we ought to try next? I can even change if you want to. We now know that's root 41. We now know this is root 41 plus B. We now know this is root 41. Which one do you think is going to be easiest to do next? B or C? Give me a vote. How many think B is easier to do next? How many think C? Let's see. Tilly, how would we do C? So which 2 triangles are you going to look at for C? Just help me get focused the right place to start. So the left, middle, right, the left, and which other one? All the way over there with the line going through. So the left and the middle. And so look at those 2. And then you said something about some ratios because they are what kind of triangles? Similar triangles. So what ratios might we set up using similar triangles? Thumbs up, thumbs down. Does that make sense to everybody? So if we, what? Question? Okay. So 5C equals 32. So divide both sides by 5, not the nicest number in the world. but C is 32/5. Okay, that leaves B. So let's think through our choices for B now. I could do Pythagorean theorem here. I could do 8 squared plus the C squared that I just found, that fraction, and square it, equals root 41 plus B times root 41 plus B. Do you like the sound of that one? That seems awfully messy to me. Let's see if one of the other ways is going to be any easier. I could do root 41 over root 41 plus B equals 5/8. That's better. Let's see what the other one was. Maybe we'll go with that one, but let's see what proportional line segments would give us. If we came over here, can anybody tell me how we would set that up with proportional line segments? We've got these two parallel lines. So what over what equals what over what? Who can tell me? Oh, come on, one of you can. How does proportional line segments work? You know, we're saying that these two lines are parallel. So root 41 over B equals 5/3. What do you think? Is that the easiest? I like that better than having to have a root 41 over root 41 plus B, which I'd have to if I did the similar triangles. So let's just do our cross product here. 5B equals 3 root 41. Divide both sides by 5. And B is 3 root 41 over 5 using our proportional line segments. What was your question? Okay, we know A is root 41. These two lines are parallel. Proportional line segments back what? First week of the semester? When we have these parallel lines, two transversals, this piece over this piece equals this piece over this piece. Any other questions? All right, grab the whiteboards and you get to do some practice.